Look at confidence intervals. This is sort of the second part, and this is for comparisons. And so we've done early in the week, we've done for single values, and now we take some of the same stuff and we look at comparing. And often you'll hear in the news or otherwise, oh, this has changed, people used to support this, now they don't, or something like that. And when we apply the whole confidence interval idea to those statistics, then sometimes the answer isn't as clear as is implied. Now, there is a couple of things to be remembered, and they're not given in the formula sheet, so we need to commit to memory this. Okay, we're dealing with where we're looking at the difference between two percentages and deciding whether it's statistically different. What we're going to do in each case is we're going to find the difference, we're going to find the margin of error, and then we're going to make a confidence interval that isn't for the actual percentages, it's for the difference between the two, and that's quite important in terms of understanding what we're going to go through. Now, there's two different formulas because there's two conditions. So this is the first condition. When the two things we're comparing are taken from the same group and from the same survey. So that's what we'll look at first. This formula goes with that. So an example would be this. If Labour is polling with 39% and National 43 from the same Colmar Brompton poll at 1,000 people been asked, can we be sure really that National is ahead? Okay, so we're going to use the difference plus or minus two lots of the margin of error because there's two percentages involved. So we work through it from left to right. The difference is only 4%, 43 minus 39. The sample size is 1,000. The margin of error for 1,000 is 3.2, and we're just still using the 1 over root n, the rule of thumb that we've been using. That hasn't changed, and it doesn't change. So now this is the thing here, this is the beast. So we apply that. So we go 4 plus or minus, so it's going to give an upper and a lower value, times 3.2. Now, when we do that, 4 plus or minus 6.4, because that's two lots of 3.2, we get this as our margin, our confidence interval. Now, this is a confidence interval for the difference, and interpreting it is important. The 10.4 implies, in this case, because we're looking at National being ahead of Labour, we're saying at the maximum, according to this, if we apply a margin of error, National could in fact be up to 10.4% ahead. On the other end of the scale, though, we've got a negative, and the negative 0.24 implies that actually there's potential for it to be the other way around, because negative 0.24 would actually imply that, it is possible, even considering the results of this poll, that Labour is 2.4% ahead, although in the poll they were 4% behind. Now, somewhere between those two numbers is 0, and if you think about it, and this is good logic, 0 difference implies that they're both the same. If our confidence interval spans from a negative number to a positive number, 0 has to be on our interval, and 0 implies they're the same. And so our conclusion sentence is in red here. The 95% confidence interval includes 0 and negatives, so it is possible that they are equal or that Labour is ahead by up to 2.4%. So we do not have statistical support, or actually the word more commonly used, and I'll just change that as we go, statistical evidence for a difference. And now that's one situation where it's all of those people polled were from the same group in the same survey. Now there's another example in the notes there. I'll just let people see that briefly. If you're looking at it, you could pause your clip, have a look at the question, and check that my working in blue makes sense. Okay, but I'm going to move on now to the second situation, and that's this. Type 2 is comparisons between two different surveys or two groups within a survey. Now, we use a slightly different formula, this one here, and here we're using the difference, so that hasn't changed, plus or minus, that hasn't changed, but now we use 1.5 times the average margin of error. Now, there's a little bit of fiddling around with this, and there's a little bit of work. So if we look at an example, I've done a touch of color coding, e.g., 2 polls are taken on legalization of cannabis. As you come to voting age, this is something that you will be voting on when there's an election, which September, October, November sometime. So these are 2 different polls asking the same question of different people on completely different years. So in 2012, they found 38% supported. These are completely fictitious numbers on a poll of 700 people asked. And in 2018, a similar poll was run and the support had dropped to 32.6. And that was actually based on, according to these fictitious results, a larger group. Now, I would imagine, actually, I've probably got this completely the wrong way around. But anyway, that's not the point. We can do the maths anyway. Is the support really dropping? That's the question. Or is there statistical evidence for the support for the legalization of cannabis dropping? That would be a better way of wording that. Okay, so what do? We've got a few numbers to deal with here. The difference is reasonably simple. We go 38 minus the 32.6. So the difference initially between the two, we see a drop of 5.4%. So it has dropped according to the surveys anyway. Now, I've done the green figures here. There were 700 people and the margin of error for 700, and that's just using 1 divided by the square root of 700 times 100 gives you 3.8%. If we ask 1,000 people, we're used to this one because it's just like a Colmar-Brunton poll, 3.2. But what we're required to do, because we're required to average them. Now, there's various ways of looking at this. Averaging here, this is one way of looking at it. No, I just want the first part. Take the 3.8 plus the 3.2, press equals on your calculator or put a bracket around it, and then divide by 2. The average of them is then multiplied by 1.5. Now the average of those two would be 3.5. So the bit that I've got highlighted at the moment would come to 3.5. Check that on your calculator, make sure you're getting it. Equal sign at the end of the top line is the best way to go. And then multiply it by 1.5 and you'll get the 5.3. Now, if we apply this, what is important is the 5.3 is less than the actual distance. That's really what we care about in practice. If I then add the 5.3, I get 10.7. So the drop or the decline in support could be as much as 10, nearly 11%. That's what that says. And the 0.01 means the decline could be, once we apply a margin of error to both, as little as 0.1%. Now, this is dangerously close to 0, but it's still more than 0. So even at the extreme low end, we've got implication of a drop in support. So our conclusion would be we're 95% confident that the true drop in support is between 0.1% and 10.7. So 0 is not included in the interval. And I might word that differently. And would say rather than 0, we'll drop 0. As 0 is not included in the interval, throw a comma in there for good measure, we do have statistical support for there being a decrease in the support for the legalization of cannabis from 2012 to 2018 in New Zealand. Right. Now, I do have another worked example here, which I'll just show on the clip. I'll get that up before I finish so that if you were using the clip, you could have a look at this. So I get it right there, you can see the whole thing in one go. The reason I'm bothered showing you this, and I know it's a bit small, is that there's a lot of figures to handle. So what I've suggested on my second example, if I was doing this in exam, I would build a small, slightly scruffier than this table, because I've got female data to consider, male data. work out those two margins, average the margin of error, and so I would consider that as an option. So that gives you some good background on comparing. The trick becomes when you're reading a question, you have to decide which one is it. Okay, and that takes a little practice.